Okay, so we're on 6.1, day 2. The ambiguous case, side angle. Remember your geometry teachers, if they were like me, they said, oh no, if you can't have side angle, that's a bad word. And this is why, it's this ambiguous case. So if we are going to, if we are given two sides and the angle opposite of the two sides, the given information may result in one triangle, two triangles, or no triangles. Side angle is known as the ambiguous case. When we're using the law of sines, the given information may result in one triangle, two triangles, or no triangles at all. So we're going to go through each of those. Okay, the first part. Consider this, and then maybe this is the result. So if A is greater than H and A is greater than B, one triangle is formed. So if A is greater than H and A is greater than B, one triangle is formed. Okay. Okay, if A equals H and is just the right length, it is just the right length to form a right triangle. So this is if A equals H. Okay. No triangle is formed if A is less than H and is not long enough to form a triangle. Then there's one more. So we don't have the ability to just scroll through them because my desktop does not, well, I don't have a desktop. So I can't download that program. So I have to take pictures of all of our slides. So that's why you see me going there and selecting them out of the pictures. So this is the other issue, is if A is greater than H and A is less than B, two distinct triangles are formed. So this is the big one. Huge deal here. For example 3, I always begin by trying to draw a triangle so I can visualize. You know me. A, B, C. So angle A is 50, side A is 10, and side B is 20. Okay, so we begin by testing out and finding the value of H. We saw on those other pages that H is B sine of A. My value of B is 20. Sine of angle A is 50. Again, it doesn't have to be labeled the same letters, just as long as you have that relationship occurring. And when we do this, we arrive at 15.32. So then we want to compare A and H. Well, if A is 10 and H is 15.32, we see that A is less than H. And the case where that occurs is no triangle. So instead of just jumping into work, see there's no triangle. You could have set up the law of sines, but when you did try to find angle B, you would have arrived at 1.53 and then try to take the inverse of it. It won't allow you. So you see that there would have been something going on there. So we know this is our correct solution because A is less than H. And we found that value of H. Okay, example 4. We're doing the same thing again. This one I did not draw a triangle. I just jumped right in. So I had H equals 16 sine of 35. Okay, which is approximately 9.18. So we're going to compare A and H. Well, A is 12 and H is 9.18. So A is greater than H. Okay. So now that we know that A is greater than H, now we have to compare A and B. So we know A and B, 12, and my B value was 16. We see that A is less than B. And because you have A greater than H, but A less than B, two triangles are formed. One acute and one obtuse. we can get this by 180 minus our angle. Okay, so we're going to get started over here. I'm going to start here with A sine of A equals B sine of B. Substituting in what I know. We're going to solve for sine of B, so I get 12 sine of B equals 16 sine of 35 divided by 12. Sine of B, should be a capital B because it's an angle, equals, is approximately, it should be the proper, 7.7648. You got to do a sine inverse if you're finding the angle, just as a nice reminder. Okay, so right here we get a 50 degrees. And now that we've done this, there are two angles between 0 and 180 where this occurs. Two angles where this occurs. So we can now do B1 is 50, or you could have B2, which is going to be 180 minus 50, which is 130. So to find C for B1, so C1, that's going to be 180 minus 50 minus 35, which is 95. And C2, it's going to be 180 minus 130 minus 35, which is 15 degrees. Okay, I'm going to need some space, so I'm going to erase that first half again. So triangle 1. And then triangle 2. So triangle 1, we know A equals 35 degrees. B, we just found, was 51 or 50 degrees. C, by using that 180, we got 95 degrees. We know A is 12 and B is 16. So the only thing we're solving for here is now C. So we can do 16 over sine of 50 equals C of sine of 95. So important things here. We had to use the B angle because it's the one that has the two options when trying to find C. If you use the A angle, we would have gotten the same value. So you have to use the B to find the missing angle or the missing side. So now we can solve this by having 16 sine of 95 equals C sine of 50 divided over by sine of 50. C equals, or C is approximately, is more accurate, 20.8. So I'm going to go back up here, 20.8, and that's my first solution. The second one, we go through again. We have A being that 35, B2, you guys just told me, well, I found it, I guess, 130, and C2, which is 15. We know A is 12. We know B is 16. And so to find C, we have that 16. Again, you have to use that B sine 130 equals C over sine of 15. We do our cross multiplication. We get C sine of 130 equals 16 sine of 15. Sorry, guys, I got a phone call. So we're going to divide each side by sine of 130. And as this occurs, you get C equals 5.4. So C equals 5.4. So notice this case, you have two of them with the 2. You have to use, you have to find angle B using the law of sines, then find angle C using minus 180 minus the two angles you have. You need to find the other option of B by doing 180 minus your out value of B1. And then you've got to do law of sines to find angle C, or side C, I'm sorry, because we know angle C by 180 minus those two other angles. And then we have two different triangles, an acute and an obtuse triangle being formed. We have some try it yourselves. If you guys want to try those and then let me know, I'm happy to go through those with you. But for right now, we're just going to move on to our next topic, which is going to be finding the area of these type of triangles. So I'm going to go here. We should be on this one. Area of an oblique triangle. The area of a triangle equals 1/2 the product of the lengths of two sides. Let's try again. Lengths of two sides times the sine of the other included angle. The figure is wording can be expressed by the formulas. Area equals 1/2 BC sine A, or 1/2 AB sine C, or 1/2 AC sine B. The one thing you have to realize here is whatever the two sides are, the angle is going to be the one that's not with those sides. Okay, so find the area of a triangle having side lengths 8 and 12 meters and the included angle being 135. Okay, so we can do this as 1/2. So area equals 1/2 A B sine C. So we have 1/2 8 meters times 12 meters times sine of 135. You could put this all in your calculator at once, and we get 34 meters squared because it is an area. Okay, guys, this is our second day of this lesson. Please let me know if you have questions. Please try some of these out.